Thank you. Don't forget to upload at the end too. Brigand is a meta-programming library. We started with Joel. It started out of our own need because in our software and the software of Joel, we make heavy use of template meta-programming. And it's basically, the pitch is Boost MPL for C++ 11.14, and it works on Visual Studio 2013, Clang, GCC, any compiler you want. So it's one of the two, obviously, second one. The idea comes that I just started to write open source the library we had internally at the company. And then Joel said, what is the brigand thing you're doing right now? And say, okay, now we're going to call the library brigand. Brigand the thief. Or, yeah. Source of inspiration. Whenever we had an idea about how we should do it, what interface we should have, what we did is simple. We said, how is it done in Boost MPL? So if you already use Boost MPL, getting it to Boost Brigand is going, it's not Boost Brigand, lapse. It's going to be very easy. And actually, when I started, it was the article written by Peter Dimoff which gave me the idea to write the library, because I realized it would be actually very easy. And also, of course, ideas from Eric Niebler as well. Three very important goals. It must be instant compile time. And when I say instant compile time, it takes 10 seconds to build the whole library with every test, and we have like, how many tests? 1,000?
100,
okay.
Almost 200.
Okay, so 200, 2,000. We have many, many tests. It's instant compile time, whatever the complexity, because we make heavy use of C++ 11 features, periodic templates. There is not a single macro in the library. It's purely C++. Sustainable code base, yeah, like you want to do metaprogramming, but you don't want to kill yourself in 2 years. And wide support, the software we use also has to run on Windows, so it has to compile on Visual Studio 2013, and it's also work on Visual Studio 2015. It's Clang 3.5, 3.6. We tested on the default Clang from macOS, GCC 4.7? 8, okay, 4.8, 4.9, 5.0.
Wait, another point you can go back is
yes.
When the other point, which is all about the sustainability of the library, is that it has to be simple to use, but that's basically what the interface inherited from the MPL gave us. But we also wanted it to be easy to look into, because we don't want our coworker to be lagging behind what's going on into this piece of software. So we try to keep the implementation as straightforward or trivial as possible.
The clicker doesn't work.
You broke everything
Can my
again.
assistant please change the slide? Yes, so what do we use Brigand for instead of just playing around with C++? Compile time checks, obviously, constant computations. In QuasarDB, we don't really write the protocol. We generate it, serialization. And what do you use it for as well, exactly?
So we use it to handle different kind of problems related to memory layout. Sorry. So we have some kind of automatic structure of array to array of structures converter. So you can actually write an array of structures, and we generate the properly decentrally memory layout on the fly. We do that. We have something that's compute complex function return times, where you try to build a large data flow that combines multiple tuples and stuff like that.
And it's available with the Boost software license, so you can just use it and just use it. Okay.
So in terms of features, what's that? Okay. So in terms of features, what we tried to do was to be as close as MPL as possible, because even if MPL starts to be aging a bit, the basic API is basically what you need. We basically have everything in terms of algorithms. We have all the classical sequences, but in fact, the main point is that everything is a type list, actually. So if you want to use a Boost variant, as a type list and you want to turn the boost variant of integers to a boost variant of the equivalent floating point types, you just can pass boost variant of something to brigand and it will just work. You don't need to adapt that. And we get rid also of all the iterator-based API because that was a bit cumbersome. So everything works like it's a range, actually. And everything else is classical. We also have a bit of runtime. Yes. Oh, okay. We also have a bit of runtime support. So we have a proper implementation of for each args. We have something akin to a static if that let you select different branches in different lambdas, stuff like this. We show it inside because basically it's useful because you start computing types and you end up wanting to take the decisions to make something at runtime. And all the other actual stuff. We also support placeholders-based lambdas, so you can actually build large, complex lambda expressions. And as I say, we wanted to work with Visual Studio 2013, and everything is macro-free, actually. So it's straightforward to read if you really want to look into the implementation. What the heck is this stuff? No, it doesn't function, yeah. You broke everything again. Okay. So this is the kind of stuff we can actually write. That's very, very rough and simplified example. So you can build a list of types, including with void inside that some of the library doesn't support. And you can just transform it to add a pointer on everything. Okay, and you turn that into a STD tuple. Done. And as I say, everything is type list, so you can do exactly the same, but using directly a variant. Should be boost variant, actually. Yes. The STD variant is not there, so anyway. So, well, we have boost variant of some stuff. You just take it, pass it to the same kind of transform, and you turn it into a tuple afterwards. Okay. So as long as you have a type which is basically looking like sometimes brackets, types, it's a brigand type list. Okay, and we don't ask you anything about that. So that's the main goal.
My remote doesn't work.
And as I say, we have this range-based interface. We shamelessly take from what Andre and Alexander School said about D. So let's say you have this brigand list of stuff, okay, and you want to try the first int inside that, okay. So you basically get that. So you can also find elements to get directly to the types. And the result is not an iterator or whatever. It's basically we consume the type list until we found whatever we need to find. And we return you the type list with the first element being the first stuff that verifies the predicates. So either you can take that and you know that the front of this is what you want. And you can actually push it back to another call to find if you want to find the second one and so on and so on. So you doesn't have to deal with meta-iterator like MPL, dref, and stuff like this.
It's the end.
And okay, so it's on GitHub. We worked hard to try to have something that actually compiles tonight, so you can actually try the actual first release, okay? And tell us if it doesn't work, where, why, when, and we really appreciate it to get any feedback on that. Thank you.